Alright, so here's the tutorial on how to make the arcade drive with proportional control uh, over the maximum output. So basically, we have to start by looking at some theory about it. I found this little file pretty interesting on the internet. I'll put the link in the description below. Uh, Basically, imagine this is your joystick. The new joysticks are in a circle pattern, but it doesn't really matter. Uh, so basically, here is the center when channel 1 and channel 2 are worth 0, and if you go forward, then the two motors, the left motor and the right motor, they should have a value of 100%. If you go backwards, then it's minus 100, minus 100. Or in that case, it would be 127, but let's keep it to 100 for keeping things simple. So, plus 100 on both sides, minus on both sides. If you want to turn left, then it's minus 100 to the left, plus 100 to the right, and vice versa for turning right. If you want to swerve, make kind of a curve instead of turning around, instead of the robot turning around itself, then it makes a curve, then you stop one motor and you put the other one full throttle. That's the diagonal option. So basically, that's the 8th options you get, and everything in between has to be coded too, but that's gonna get coded with this algorithm. Now, this is pure C programming. I'm gonna help you guys with translating this to easy C standards. So let's get to it. So first of all, we're gonna need variables. So we'll go make some global variables. As for the tank drive, we're gonna use a float that we called last time. We called it rate, so we'll call it rate again, and we'll give it. Let's say we want 80% of the speed of the motor, so percentage of the speed of the motors. So that's the rate at which we're gonna multiply the motor output, so it's gonna be slower. Afterwards, we're gonna put some ints. Normally we would use chars, but in these cases we're gonna use ints because we're gonna use the absolute value function that needs ints and not chars. So we're gonna put one int called channel 1, one int called channel 2, because we're gonna use the right joystick. If you want to use the left joystick, then you use channel 3 and channel 4. That's not such a problem. Afterwards, we're gonna need an int called max for the maximum value, an int called sum, an int called diff, and we're gonna take a char and call it deadband. There we go. The deadband, we're gonna set it to 10. Alright, so let's go in operator control. If I put all the coding in there, it's going to be kind of messy. There's going to be lots of stuff. So I'm going to create a user function, a custom function that I'm going to call arcade with rate. And yeah, no need for arguments. It's going to return a void. I'm not going into details. But there you go, you press OK, and it opens a new tab with a blank sheet, and you can code everything there. And afterwards, in operator control, you just drag and drop arcade with rate in there, press OK, and well, there you go. So, arcade with rate. First of all, we're going to need to check on the joystick the values of the joystick. So check on the controller number 1, channel number 1, retrieve it to channel number 1, the variable, and do the same thing for channel number 2 to CH2. There we go. So afterwards, we check the values, store them in the variable, then you get joystick analog deadband. So if the value is too small, so within the deadband, which is from -10 to +10, then it gets nullified to 0 for channel 1 and for channel 2. Deadband, deadband. There we go. Afterwards, once this is done, we get our signal, we get our cleaned up signal, and the fun starts. Program flow. We're going to assign a value. We're going to decide what is the maximum value between channel 1 and channel 2. So what we're going to do, we're going to say maximum is equal to channel 1. So we're going to say that the maximum is actually not channel 1, but the absolute value. So ABS, parentheses, and parentheses at the end. So the absolute value of channel 1. And afterwards, we're going to check if the maximum is really channel 1, if it's not channel 2. So if the absolute value of channel 2 is greater than the maximum being at the moment the absolute value of channel 1. So if this is true, then, well, the maximum is not the absolute value of channel 1, it's going to be the absolute value of channel 2. So maximum equals absolute value of channel 2. And there we go. So now we have defined what is our maximum, what is our minimum. Now we're going to assign a value to the sum variable, which is going to be sum equals to channel 1 plus channel 2. And we're going to assign a value to the difference variable. So difference is equal to channel 1 minus channel 2. There we go. So we have assigned every variable that we needed. Note that all of this coding that I'm going to do is valid when forwards mean that both motors run at positive full throttle, backwards at negative full throttle, and that the left motor is really plugged in the left motor and the right motor is really plugged in the right motor. I strongly suggest that you check your wiring, your electricity, in order to see if it's really the case. If not, well, the function will not work. Then you'll have to check what motor is at fault. If you have to switch between the two motors or switch the polarities of the motors, that's up to you. But you'll eventually get it. All right, so let's do some more complex stuff. If channel 2, so if channel 2 is smaller or equal to 0, if channel 2 is smaller or equal to 0, we're going to have to check channel 1. So if channel 1 is greater or equal to 0, so if something, we have imbricated ifs here. It's normal. It's okay. It's not a sin. So you can do it. So in that particular case, so channel 2 is positive, is negative, and channel 1 is positive, then we can assign some values to the motors. So the left motor will be equal to rate times max. And be very careful that because you really have to put all uppercases that you defined as variables in uppercases and lowercases as lowercases. Coding is case sensitive. So rate times maximum, that's for the left motor. If we want to know what happens to the right motor, so the right motor, we give it the value of rate times -1 times sum. So rate times max, rate times -1 times sum. Okay, so that's one case. We have 4 cases. So that's the first one. If channel 2 is negative and channel 1 is positive, that's that case. If channel 1 is negative, we have else. So channel 2 is still negative, but channel 1 is not positive, therefore it's negative. Then we have that case. Motor module. Left motor. Motor number 2. We give it the value of rate times diff. Yeah, and that's left motor. For the right motor, we give it the value of rate times maximum. Right motor. So we have the 2 cases of channel 2 being negative that are being taken. Now let's see what happens when channel 2 is positive, when we're going forwards. So that was backwards. Now this is forwards. We're going to put another if right here. So if channel 1 is positive, then the left motor has to take the value of rate times diff. Yep, that's the left motor. And the right motor has to take the value of rate times -1 times maximum, or just max actually. So that's the right motor. So that's case number 3, when actually channel 2 is positive and channel 1 is positive. And the last of the 4 cases is when we have positive channel 2 and negative channel 1. And then we'll have the left motor going rate times -1 times maximum. And for the right motor, we're gonna have rate times -1 times sum. That's for the right motor. All right, so basically we have 4 set of actions for all the 4 cases, for which for where the joystick is, and well, if we take a look at the plan we had like a Cartesian plan. We have the first quarter, second quarter, third, and fourth. That's our 4 cases. So there we go. That's the arcade with rate drive. Unfortunately I don't have a robot with me at home, so I cannot test it for the moment. However, I will test it, and I have some issues. I think I'm not sure that the rate will function properly, because some here can be, and difference too, can be greater than 127, and this one too can be greater than 127, and well, that might pose a problem, because well, your rate is going to be off. A pretty easy solution would be to lower the rate until it gets responsive. Another solution would be to add if cases. So if sum is greater than 127, then sum equals 127. If sum is lower than minus 127, then sum equals minus 127, and etc. So that's another way to do it. I'll leave that up to you guys. Play with it, see what works, what doesn't, and eventually you'll find the right solution. So basically, all of this coding is taking away from the operator control via this pretty cool custom function. So we have only one item instead of all of this, which is pretty neat. And yeah, so that's arcade with rate. Good luck, guys.